Hello students and welcome to our today's class. In our today's class, we are going to discuss about the determinant and the inverse of a 3 by 3 matrix. So far, we have discussed how to get the determinant and the inverse of a 2 by 2 matrix. So in this case now, we also want to see if you are presented with a 3 by 3 matrix, how should we go around and determine the determinant and also the inverse of that particular 3 by 3 matrix. First of all, we need to understand what is a 3 by 3 matrix. A 3 by 3 matrix, it is simply a matrix that has got 3 rows and 3 columns. So we are going to have a matrix like a matrix of that nature is a 3 by 3 matrix because it has got 3 rows, 3 columns. So it is a 3 by 3 matrix. So our discussion will start by determining the determinant, which we normally denote by det. How should we get the determinant over a 3 by 3 matrix? We saw when we are given a 2 by 2 matrix, the determinant of a 2 by 2 matrix is given by the difference between the product of the main diagonal and the secondary diagonal. That is actually very easy or very simple for you. If you have A, B, C, D, which is a 2 by 2 matrix, 2 rows, 2 columns, we normally multiply the elements of the leading diagonal, and then we also multiply the elements in the second diagonal, then we minus the two products. So it is actually AD minus CB. That is actually what we did. What about now if you are given a matrix that is 3 by 3? How should we go about it? This is actually the procedure. This is actually the procedure. So if you are given a matrix A, B, C, D, E, F, G, H, I, you are given that matrix and you are told find the determinant, which is det. So what you need to do is to rewrite this matrix the way it is. You rewrite it like that, and then you repeat the two first columns. The first two columns, you repeat them on the right-hand side. So we have A, D, G, you repeat this, and you also repeat this, B, E, and H, like that. So that now you can have an enlarged matrix. Then what you do now, you come from this corner here. From this corner here, you draw the lines. You can draw that line that is passing through these 3 elements. We also have this one that is passing through this element, and you also have this one that is passing through these elements like that. Then you have got this other end. From here, you draw a line passing through those 3 elements. You also draw another line passing through those 3. You also draw a line passing through those 3 elements like that. Having done that, now the determinant is going to be given by the sum of the product of these diagonals, the sum of the product of these 3 diagonals minus the sum of the product of these other diagonals. Remember, these diagonals that are sloping from top left to bottom right are actually our main diagonals. So it is the sum of the product of these main diagonals minus the sum of the product of the secondary diagonals. So in this case, we are going to find it by, this is C, E, G. So we multiply C times E times G plus, this is A, F, H. Sorry, I think we have done the opposite. What we need to do here is actually, first of all, we start with the main diagonals, which is actually these ones. So it is supposed to be This is actually A, E, and I. Those are the main diagonals, A, E, and I, plus B, F, G, B times F times G, plus C, D, H, C times D times H. You add all those, then you minus the product of this. This is CEG. We have CEG plus AFH, AFH plus BDI. You add all those, and now you get the difference of the first bracket and the second bracket. That is going to give you the determinant. Let us have it maybe in numerical form. Like, for example, you are given a matrix like you are given a matrix like that. That is a 3 by 3. Now you are told find the determinant. So for doing this, you need to come and rewrite this matrix. Make sure you write it properly so that actually you can have those diagonals where indicated. So I have written the first matrix, then I have repeated the first two columns like that. Now, having done that, I can come here and get my determinant, which will be given by, first of all, drawing the lines. You come from this corner, and draw the diagonal. So we start with that first diagonal there. You come here, you draw another diagonal. You come here, you draw another diagonal like that. Those are the main diagonals. Then come here from this corner, draw that diagonal, draw the second, draw the third. Make sure that each diagonal is touching 3 elements. Each diagonal is touching 3 elements like that. So our determinant will be the sum of the product of the main diagonals. So it's going to be 1 times 5 times 9, 1 times 5 times 9, which is actually 45, plus 2 times 6 times 7. 2 times 6 is 12. Then we do 12 times 7, which is actually 84. So we have it here as 84 plus, this is 3 times 4 times 8. That is 12 times 8, which is actually 96. Minus the sum of the product of the other diagonals. That is 7. We have got 7 times 5 times 3. That is times 5 times 3. You get it is 105 plus the product of this, 8 times 6, 48, plus this is 942. 72. So it is going to be given by 45 plus 84 plus 96, 225 minus minus 225 actually. So you find the determinant here is going to be 0. So that is how we get the determinant of a 3 by 3 matrix. Though we have the other procedure, but this one is the easiest, and I encourage you to make use of this. Let us see another example before we go to the inverse. So you can be given another matrix like this, 2, 0, 9, 4, 1, 3, 6, -1, -4. You are told you find that, find the determinant. So one thing you need to come and do is to rewrite the matrix 2, 0, 9, 4, 1, 3, 6, -1, -4. Then you repeat the first two matrices, or first two columns, sorry. Then what are you going to get? Come to this corner, draw a line, come to this, draw another one, come to this, draw another one. Then come to this end, draw a diagonal, draw another one, and draw another one. So let us get now our det will be given by 2, 1, -4 is going to be -8 plus, this is 0 times anything is going to be 0 plus, this is 9 times 4 times -1 is going to be -36. Then you minus, we have 6 times 1 times 9, which is 54, plus we have got -1 times 3 times 2, it's going to be -6, plus 4 times -4 times -4 times 0 is going to be actually 0. So if you do the difference, first of all, we add each bracket. This is the same as -8 minus 36. Minus 36 minus 8 is going to be -44. Minus, this is 54 minus 6. 48. So going to be -44. -44 minus 48, -92. That is your determinant. As simple as that. Having known how to do the determinant of a 3 by 3 matrix, now we can talk about how do we get the inverse of a 3 by 3 matrix. This process is actually going to involve a number of steps. The first thing that you'll be required to do, let me come here. For example, you are told to get the inverse of this matrix, which is 209, 413, 209, 413, 209, 413, and then we have the last row, which is the 6, -4, 6, -1, -4. 6, -1, -4. So the question was asking, find the inverse. The process of getting the inverse of a 3 by 3 matrix, number one, you will be required, step number one, you find data, we find the determinant, which actually we have calculated here, and our determinant is -92. So that in this case is -92. That is step number one. Step number two is to find cofactor matrix. Find the cofactor matrix, which is actually a process. So finding the cofactor matrix will involve, number one, find reduced 2 by 2 matrices, which I want us to do here. If we have 2, 0, 9, 4, 1, 3, 4, 1, 3, and then we have 6, -1, -4. If we have to do or to find the reduced matrices, 2 by 2 matrices, you come here, you do it like this. Come here. If we delete this row and this column where 2 belongs to this row and this column. If we delete this and we delete this, what we are going to remain with is 1, 3, -1, 4. So you have it 1, 3, -1, -4. Come here. Then the second element, delete the row where it belongs and the column where it belongs. If you delete this and you delete this, we are going to see 4, 3, 6, -4. Come here, delete this and delete this. We are going to see 4, 1, 6, -1. We are through with the first row. Once you reduce the first row, you come here, delete this to have this. Come here, delete this to have this. Come here, delete this, you have this. Now you have reduced the first row. Come to the second row, do the same. This 4, it belongs in this row, this column. If we delete this row, this column, we are going to see 0, 9, -1, -4. So you write it here, 0, 9. You have deleted this and this, -1, -4. Come here, the second one, delete this, you delete this, then you delete this. So we are going to see 2, 9, 4, 2, 9, 6, -4. Come here, delete this. So we are going to have 2, 0, 6, -1. Okay, we are through. You can be able to note if we are here, whatever we get, we write in that position where this element belongs. So if we come here, we delete this, we are going to see 0, 9, 0, 9. We have deleted this 1, 3. Come here, delete this 2, 9, 4, 3. Come here, delete this 2, 0, 4, 1. Remember, we are finding the cofactor matrix. So after doing that, we can get the determinants of these 2 by 2 matrices. So in this case, we have 1 times getting the 2 by 2 matrix determinant is actually what we discussed. So it's going to be the product of the reading minus the product of the second. So this is -4 minus 3, which will give us -9. Then we come here, this -16 minus 18. -16 minus 18 going to be -34. Here is going to be -4 minus 6, which is the same as -10. Come here, do the same. This is 0 minus -9. 0 minus -9 is going to be +9, which is this one is a -8 minus -8 minus 54 is going to be -62. This is -2 minus 0, so it is -2. Come here, this is 0 minus 9, -9. This is 6 minus 36, which is -30. This is 2 minus 0, which is 2. So we have that matrix that we have obtained here. Now to get the cofactor matrix, step number 2, we have find the reduced 2 by 2 matrices. Step number 2 was to find the determinant of each 2 by 2 matrix, which is actually what we have found. So we found the reduced 2 by 2, then we have found the determinant of each to get this. Step number 3 now, it will entail assign arbitrary signs. Assign arbitrary signs in the order positive, negative, positive, negative, positive, negative, positive, negative, positive. So these are the arbitrary sign. So for each like element, this one corresponds to this positive. So it is positive times this, you get it's going to remain to be -9. Negative times this negative is going to be positive 34. Positive times this negative is -10. Negative times positive 9 is going to give us -9. This is -9. This positive times this negative is remain to be -62. This negative and this negative is +4. Then we have positive and negative is -9 again. Then we are going to have negative and negative, it is +30. Then we have positive times this positive is going to be +2. So whatever you get here, this matrix is known as the cofactor matrix. That matrix is known as the cofactor matrix. How do you get the cofactor matrix? I want to repeat the steps. Number 1, find the reduced 2 by 2 matrices. You come here, you delete this, whatever it's going to be shown, you write in the position 2 was occupying. Remember 2 was number 1 here. So whatever you will see, you write it at that position. Come here, delete this column, delete this row, you are going to see 4, 3, 6, -4, you write it there. You come here, delete the row and delete the column where this 9 belongs, you see this. You do all that to get the reduced 2 by 2. Then you find the determinant of each 2 by 2 matrix that you have found to find this matrix that we have here. The matrix that you have here, you assign it arbitrary signs, and whereby this arbitrary signs, it is just a matter of starting with positive and you go alternating like that, plus, minus, plus, minus, plus, minus, plus, minus, up to this, so that they can correspond to this. So each of the element that you found here from the determinant, you multiply by its sign that corresponds to that position. So this positive corresponds to this, you multiply, you find it's going to be -9, like that. So you get this. After doing that, you have your cofactor matrix. That was number 2 step. Step number 3, you are supposed to get what you call adjoint. Determine, this is number 3, determine adjoint matrix. Adjoint matrix. And adjoint matrix is actually, this one is obtained by transpose the cofactor. Transpose the cofactor matrix. How do we transpose? Transposing simply means you change the rows to be the columns. Like in this case, our first row was having -9, 34, -10. -9, 34, -10. You write it this way now. -9, 34, -10. Instead of being a row, it becomes the column. You go to the second row where we had -9, -62, 4, which is a row. You now write it in column form. So it is going to be -9, -9, -62, 4. It becomes the second column. Then you do the same to the third row, which is -9, 32. -9, 30, and 2, like that. This is now what we call transposing. transposing. So once you transpose the cofactor matrix, what you get is called the adjoint matrix. So the inverse of 3 by 3 matrix is normally equal to 1 over determinant, then you multiply by adjoint. So in this case, our determinant was 92, negative 92. So the inverse is going to be 1 over negative 92. Then you multiply by negative 9, negative 9, negative 9, 34, negative 62, 30. That is actually the inverse of that particular matrix. You can see it involves a number of steps, but those steps are so clear and so straightforward. It's a matter of noting how to go about it, and then you are done. That is actually how we get the determinant and the inverse of a 2 by 2 matrix. Thank you very much for joining the class.